Hi, thanks for joining me for the next few minutes. We're going to discuss multiplying polynomials. So we have 8 examples that we're going to look at, and they're all just slightly different. So the first one, we have a monomial, the 5, times a binomial, the x minus 2, and we want to make sure that the monomial is applied to everything in the parentheses following it. So we want to multiply 5 times each of the 2 terms in the parentheses. So we've done this before. It's the distribution property. So 5 times x is 5x, and then 5 times negative 2 is negative 10. So 5x minus 10 is the product of 5 times the difference of x and 2. All right, number 2, this is also just the distribution property. So we're going to take that negative 3 and multiply it by each of the 2 terms inside the parentheses. So negative 3 times 2y is negative 6y, and negative 3 times negative 4 is positive 12. So the most common mistake made there is that people forget the sign, and they would just put a minus 12. And that's it. Number 3, notice this time we have a binomial times a binomial. Right? We have 2 terms in this polynomial, and we have 2 terms in this polynomial. What we're really going to do here is make sure that every term in the first polynomial is multiplied by every term in the second polynomial. So we want to do it in an organized way. Some people really like the acronym FOIL, meaning first, outer. So first would be 3x times x. Outer is 3x times 2y. Inner is the inside ones together, negative y times x. And then last is the last term of each polynomial. So that's a way to remember it. First, outer, inner, last is FOIL. But I really just like using repeated use of the distribution property. So I'm going to take this 3x and I'm just going to draw an arrow to each term in the following polynomial. And for a binomial times a binomial, it really just works out where it is FOIL. So 3x times x is 3x squared, and 3x times 2y is 6xy. I have now distributed that 3x, so I'm crossing it off, and now I'm going to distribute the negative y. So negative y times x is negative xy, and negative y times 2y is a negative 2y squared. Remember that y times y is y squared. You're adding the exponents there. So now once I do that, I want to look and see if I have any like terms. You will notice that the 2 middle terms both have an xy. So those are considered like terms. The coefficient of the second xy is understood to be a 1. So you're going to do 6 minus 1. So we'll bring down the 3x squared. We get plus 5xy because 6 minus 1 is 5. And then we bring down the negative 2y squared. And that would be the product of those 2 polynomials. Let's look at number 4. Same thing, we have 2 binomials. So I'll start with 8z times 8z. That's 64z squared. 8z times a negative 1 is negative 8z. I've distributed the 8z, so now I'm going to do the same thing with the 1. 1 times 8z is plus 8z. 1 times negative 1 is negative 1. Okay, I've now distributed everything. So I want to look for like terms. Again, my middle 2 terms are like terms. They both have z. Notice that they are opposites. I have a negative 8z plus 8z. Those are going to zero out. So those cancel and are gone. So now I just have 64z squared minus 1. These are called conjugates, these 2 factors, 8z plus 1 times 8z minus 1. So if you have the same factor, let me erase these arrows and drawings here. Notice they're really the same, right? 8z is the same and 1 is the same. The only difference is the signs are different. So when you have the product, that's called a difference of squares. And we will see this again when we start factoring, because in this section, we're multiplying it out and getting a polynomial. In a future section, we're going to start with a polynomial, so what we're getting is the answer, and then we're going to factor it and write it in factored form. So that's coming in the future. But you'll see us talk about difference of squares again soon. But look out for that. We have 4 more examples we want to look at for this section. So number 5, we have 3x plus 4 squared. Take a second to think about what you would do with that one. So there are many common mistakes made. One of the most common mistakes is that people want to apply the power rule that we learned when we did exponents, and they just want to say, okay, well, this is 9x squared plus 16 and call it done. The issue is the power rule does not apply to sums or differences. You can only use the power rule if it's all multiplying and or dividing within the parentheses. So this is not acceptable, not mathematically correct. So what you want to look at instead is, remember that this square means I'm multiplying that whole thing by itself twice. So what you want to do is write that binomial 2 times. That is the same thing as 3x plus 4 squared. Now, hopefully you see that what you need to do is distribute or FOIL. So when I FOIL, 3x times 3x is 9x squared. 3x times 4 is 12x. I've distributed the 3x. Now I'm going to go to the 4. So 4 times 3x is 12x. And then 4 times 4 is 16. So now I have distributed everything from the first set to everything in the second. I'm going to look for like terms. Here's another place people make mistakes. They cancel out these 12s because, like in number 4, the middle 2 terms canceled out. But notice that these do not cancel out because I have the same sign. In the last one, we had a positive and a negative, so they were opposites. In this one, they're both positive 12, so they don't cancel, they add to a larger number. So this is going to be 9x squared plus 24x and bring down the plus 16. And that will be the answer. So notice that if I did that shortcut that wasn't right, I got 9x squared plus 16. I'm missing that 24x. So the 9x is right, and so is the 16, but I'm missing that middle term. Okay. So number 6, hopefully you won't fall for that again. You know that you need to write this out twice and FOIL it out. So if I do that, I'm going to have y times y is y squared. Y times a negative 1 is negative y. Negative 1 times y, negative y. And negative 1 times negative 1 is a positive 1. Again, I'm going to try to add like terms. These are the same sign, so they do not cancel out. So I have y squared. Remember that these are understood to be coefficients of 1. So a negative 1 and a negative 1 make negative 2. So negative 2y and bring down the plus 1. And that's it. All right, my last 2 examples. Notice now, and you will see this less often, especially in your early math classes. As you go forward, you might see this a little more often. But we have a binomial times a trinomial. And this is an example that shows why FOIL doesn't work, because there's more than just first, outer, inner, last. So this is where it's really helpful to use repeated distribution. So let's start with the 5x. I'm going to take the 5x and I'm going to distribute it to each of the terms. There are 3 of them in the second set of parentheses. So 5x times x squared, 5x cubed. 5x times 2x, 10x squared. 5x times negative 3, negative 15x. Okay, did the 5x. Now I'm on to the negative 1. So negative 1 times x squared is negative x squared. Notice I'm writing the next one on a different line. I really like to color coordinate, and I really like to write it on a different line because then it's easier to check my work and see if I missed something or made a mistake. Also notice I'm indenting it a little bit because then I can put my like terms underneath each other, and it makes it really easy to just add straight down. Negative 1 times 2x is negative 2x. So again, my like terms are lined up. Negative 1 times a negative 3 is a plus 3. And so now that I've distributed that negative 1 all the way, I'm going to simply add these together. So 5x cubed, 10x squared minus x squared is plus 9x squared. Negative 15x and negative 2x, that's negative 17x, and then plus 3. So that would be the polynomial I get when I multiply those two given polynomials from number 7. All right, so one more. Same thing. We're going to start with the negative 3x, distribute it to all three terms in the second set of parentheses. So we will get negative 12x cubed minus 6x squared plus 3x. So I've distributed the negative 3x. And now I'm going to distribute the 1. Multiplying by 1 doesn't change the value, right? So this is just going to be 4x squared plus 2x minus 1. Now that I've distributed everything, I can add up my like terms. So I'm going to have negative 12x cubed minus 2x squared plus 5x minus 1.